So the last thing I want to talk about in section 2.3 is functions in quadratic form. This is also referred to as substitution or U substitution. So if a function is in quadratic form, we can use substitution to solve these functions. So let's take a look at this example, and I think that'll clear things up. So I have 2x to the fourth plus 5x squared minus 3 equals 0. Now this isn't in the quadratic form we're thinking of, right? That's ax squared plus bx plus c, but it's really similar. If I was to let u equal x squared and substitute that in, I'd have 2u squared plus 5u minus 3 equals 0. Well, that is in quadratic form. So what we're going to do is we will use substitution to solve these functions. So the first thing you want to do is set your function equal to 0. You're then going to identify your u and rewrite it in quadratic form. Next, you solve the quadratic equation as usual, so you can use factoring, completing the square root property, quadratic formula, everybody's favorite. So you go ahead and solve it as usual. You're going to get your u values. You then have to go ahead and resubstitute in x squared for u in this case. And that's going to help you solve your answer and give you your solution set. It's important to note that, because this is a degree 4 equation, we can have at most 4 solutions. Remember, this is where our graph would cross the x-axis, also known as our zeros. If you want to double check, go ahead and graph this function in Desmos. So let's go ahead and look at a couple examples. If I have f of x equals x squared plus x squared minus 12, I'm going to go ahead and rewrite this and set it equal to 0. I'm then going to let x squared equal u. So I now have, if you can't see that, let's talk about, why don't I rewrite it another way? So if I have x squared squared minus x squared minus 12 equals 0, now it's a little bit easier to see what our u should be. U squared minus u minus 12 equals 0. And I'm going to factor. I'm going to factor by finding the factors of AC, which is negative 12, that add up to b, which is negative 1. Well, that's going to be negative 4 and 3. So I get u minus 4 times u plus 3 equals 0. So I get u equals 4 and u equals negative 3. I then go ahead and back substitute x squared. So I have x squared equals 4 and x squared equals negative 3. I then use the square root property. So I get x equals plus or minus 2 and x equals net plus or minus I square root of 3 because I is the square root of negative 1. So these are our four possible solutions. This is where our graph crosses the x-axis. Last example for this section, I have f of x equals x plus 2 squared plus 11 times x plus 2 squared. I'm going to go ahead and substitute back in. I have f. I'm going to set this equal to 0 first. So x plus 2 squared plus 11 times x plus 2 minus 12 equals 0. U equals x plus 2. So u squared plus 11, not 11 squared, just 11 x minus 12 equals 0. So what are some factors of negative 12 that add up to 11? Well, that's going to be negative 1 and 12. So I have u minus 1 times u plus 12 equals 0. So I get u equals 1 and u equals negative 12. I then substitute back in. I have x plus 2 equals 1 and x plus 2 equals negative 12. I subtract 2. I get x equals negative 14. Subtract 2. I get x equals negative 1. And those are the two zeros of this function.